Yeah, hi everyone and welcome to our session, Microservices for Beginners. My name is Niklas Heidloff and I'm a developer advocate at IBM.
Thanks, Niklas. My name is Suedbroecker and I'm also a developer advocate. I'm happy that we, Niklas and I, can provide you a starting point when you're going to develop microservices application. So, Niklas, what is a microservice?
Yeah, thanks a lot, Thomas. In our talk today, we're going to describe the key concepts of microservices so that all of you at the end of this talk should have an understanding about what microservices are, what technologies you need, and how to get started. So let me get started now, first of all, with the definition of the term microservices. This is a definition from Wikipedia, and I think it's actually pretty good. Microservices are a software development technique that structures an application as a collection of loosely coupled services. In other words, sophisticated applications are broken down in smaller parts, and that gives you some advantages and benefits. The question is, why should you use microservices, or why should you at least consider to use microservices for certain types of your applications? And I think the number one reason is agility. Agility in multiple ways. First of all, since you don't have to deploy the application as a whole anymore, it's much easier to do frequent updates because you can only deploy the microservices that have actually changed. Also, in the worst case, if there is a problem with a new version, you can always roll back easily, which minimizes the risk when deploying new functionality. And that enables essentially a new culture of innovation in your organization. And last but not least, for us as developers, it's always important to have fun and to be productive, right? And certainly microservices and container give you that capability. Through containers, it's much easier to develop. And through microservices, you don't have to understand the application as a whole anymore. You can focus on certain parts, certain microservices. And especially for beginners, that makes it much easier to get productive very soon. In the next part, Thomas will describe some of the key technologies that are needed to build microservices.
Niklas talked about microservices. They're usually running in containers. So let me start with platforms for the orchestration of a huge amount of containers, Kubernetes and OpenShift. Kubernetes is the de facto standard platform for container orchestration and is open source. It automates many of the manual processes you need to do when you deploy, manage and scale a containerized application. It's proven and used in many companies and projects since 2015. Kubernetes gives you a great freedom with many manual configuration options to customize your deployment and run your cloud-native application. This freedom of customization can be challenging. To make the productive life more easier for developers and operations, OpenShift was invented on top of Kubernetes by Red Hat. OpenShift is open source and a certified Kubernetes platform. It's easier of use than Kubernetes and designed for enterprise. We focus on security, optimization of workloads, and to minimize the effort for the developers and operations to deploy and run their containerized applications. So let me move on with Istio. Containerized microservices application do have a lot of communication because the services talk to each other. So we need to provide a uniform way to integrate microservices communication, manage the traffic flow, enforce policies, and aggregate telemetry data. Istio is an open source service mesh platform, which adds proxies to services to control and manage the service mesh traffic. Istio is open source and had its first release in 2018. Istio is a platform which is independent and can be used, for example, in Kubernetes and OpenShift. Now, Niklas will focus with frameworks which can be used for the microservices development.
In addition to the platforms Kubernetes, OpenShift and Istio, you obviously also need programming languages to build your actual microservice. And there's a couple of different frameworks available. One of them is Jakarta for Java development. Jakarta EE used to be called JavaEE or Java Enterprise Edition. The name was changed last year when it was open sourced on eclipse.org. And the nice thing about Jakarta is that it comes with a set of rock-solid libraries that help you to build high-quality and stable applications. Another framework is Quarkus, which is relatively new. It was only released last year, and it's a great framework optimized to build container workloads. The startup times are really fast, and the memory usage is really low. And also, it's a lot of fun, believe me. Give it a try, go to quarkus.io. Another cool technology we're going to use today is MicroProfile. And you can think of MicroProfile as an extension to Jakarta EE. It's another open source project on Eclipse, and it comes with a set of tools and libraries to build microservices. The other nice thing is that MicroProfile is also available in Quarkus, so no matter whether you use Jakarta or Quarkus, you can use MicroProfile in both cases. Now, with all of these technologies in place, the question is when to use what, and how do they all fit together. On the one hand side, you have these platforms, OpenShift, Kubernetes, and Istio. On the other hand side, you have the frameworks like Jakarta, Quarkus, and MicroProfile. Now, our recommendation is to use as much platform functionality as possible. And the reason is that that allows you to manage consistently your different microservices, no matter how they have been implemented. There are certain cases, however, where you cannot use the platform because the platform simply doesn't provide the necessary functionality. In that case, you should use the frameworks like MicroProfile, for example, in order to do application-specific health checks or authorization. In the next part, Thomas will introduce an example that we have built that will demonstrate many of these functions that we already talked about.
Thanks, Niklas. Here you see the front end of our example application. The front end simply shows articles with detailed authors information, but the example is not too small, like a Hello World example application, and is not too complex as a production example. It has the right size to understand complex topics when you start with microservices applications. So let us take a look at the architecture. As you see, this is an end-to-end example which has 3 microservices and 1 web front-end application implemented in Vue.js. This example implemented an front-end to back-end pattern with a RESTful architecture. The Web API microservice is implemented in Java and provides an API with the needed business data encoder for the front end and collects the data from the articles microservice, which is implemented also in Java, and the authors microservice, which is implemented in Node.js. So in that example, we have different programming languages to reflect that programming language is not really relevant for working with microservices application. It is more about APIs and RESTful architecture. The example also shows how to access optional cloud services, in this case a non-SQL database and the SQL database. So, Niklas, let's start with the concrete setup of the microservices containers.
Okay, after this short introduction, let's get more concrete now and let me show you some code. The first thing you need is a container and an image. And this is a definition of a container image from docker.com. A container image is a lightweight, standalone executable package of software that includes everything needed to run an application. In other words, you put everything in one container, the operating system, the application server or runtime, and obviously also your implementation of your microservice plus all necessary dependencies. Now, the nice thing is once you have done that, you can ship your container very easily to different environments. Different public clouds, on-premises data centers, or even your local development machine. The other nice thing about containers is that everything in a container is isolated, so you can run multiple of these containers on the same host, which makes it usually much more efficient than running classic virtual machines. So let's take a look how you define one of these images. And this is what you can see here in the right column. It's a Docker file. It has only 3 lines of code. I'm using here OpenLiberty. OpenLiberty is the open source IBM application server, and it provides an image that we can reuse here. And all we have to do additionally is to essentially copy our microservice and some server configuration on it, the server XML and the WAR file. And that's it. Very simple. Now, the nice thing is that this predefined image comes with really cool technologies. For example, OpenJ9. OpenJ9 is the IBM open source Java virtual machine, and it's really great. It only uses half of the memory compared to other classic Java virtual machines, and the startup times are almost double as fast as other virtual machines. So highly recommendable to use this Java virtual machine, not only for containers, but for all Java workloads. The other component that I'm using here is OpenJDK, and I'm using the version from Adopt OpenJDK because it's free and I get my security updates. And obviously the image also contains OpenLiberty, and as I said, that one comes with MicroProfile. Now, building a first image is easy, as you can see, only 3 lines of code. There are many developers, though, who don't even want to do that. They want to write Java code, which is perfectly valid, right? And fortunately, there are some tools that allow you to do that. In other words, they hide the complexity of Docker files and YAML files. And one of these tools is Odo, which stands for OpenShift Do. It's essentially only a CLI. It's kind of similar to Cloud Foundry, to the CF push experience, and you have here the counterpart Odo push. So you write your code locally, let's say a Quarkus application, you do an Odo push, and that deploys the application automatically to Kubernetes or OpenShift. It also comes with another command called Odo watch, and that allows you to edit your code locally, and whenever you save it, it's redeployed automatically to your Kubernetes or OpenShift system, and you can try your changes immediately.
Okay, Niklas, let me take over. It's time for REST APIs. I highlighted that we use the RESTful architecture in our example. Our microservices to provide REST APIs and to consume REST APIs. How to create a REST API endpoint in Java is well known. You just use JAX-RS. So let me talk about how to consume a REST API with MicroProfile. Here's a bit code how to consume a REST API in one of our microservices using MicroProfile. Here you see 2 classes. One class is called authorService, which defines an interface to the REST endpoint of our authors microservice, which is implemented in Node.js. The code looks very similar to a REST point implementation with JAX-RS. It uses the annotation get and produce, but it defines our REST client interface. The endpoint will produce JSON, as you see. We define the response type as author. The author class is implemented, for example, with JSONB and provides an automation for serialization and deserialization for JSON values so that we can easily use the return values of the response. The second class is called authors data access class and invokes the REST endpoint, as you can see. A Java REST client will be automatically created for us when we provide the interface specification to the client builder in the authors service data access class, as you see in the code. Now my colleague Niklas will move on with the topic traffic management. Niklas, your turn.
Yeah, Thomas introduced earlier already Istio, which is a service mesh technology. And Istio comes with a lot of great functionality. For example, you can easily encrypt the traffic between your microservices. Another cool function is traffic management. And in order to demonstrate that, we have extended our example. We have introduced here a second version of the Web API service. This is the first version. It lists 5 links to blog articles, and the second version displays 10 entries. So just a minor difference here. And what we want to do now is to split traffic between these 2 different versions, which is necessary and important if you want to do things like canary rollouts, A/B testing, or blue-green deployments. Now let's take a look how this works in Istio. This is a YAML file. You simply define declaratively how you want to split the traffic here. In this case, we use a splitting 80 to 20%. You can do also much more. You can, for example, define that you want to provide another version to a mobile client compared to a desktop client or a browser. So really easy to do. And the other nice thing here is that Istio comes with a tool called Kiali. It's integrated, or at least it's an optional component. And that tool gives you a graphical user interface that shows the actual traffic routing and the structure of your application. So while this diagram looks very similar to our architecture diagram, this is something that Istio calculated automatically. So we haven't drawn any boxes here. This is something that is real data, and you can use it to see how the traffic flows. You can simulate the traffic, and you can also see where errors are, for example, if HTTP error codes are returned. And in this case, you can see that in fact, the traffic is split 80 to 20%.
Thanks, Niklas. Now it's time for resiliency. Nobody likes ugly error messages and no response on a front end as a user. Resiliency is key in every application. That means also in a microservices application. We should handle, for example, potential communication problems very flexible and user-friendly. In our case, we want to ensure our front end shows at any time articles, even if the articles microservice and authors microservices are not available. In our case, the web API microservice implemented in Java is responsible for doing that job. So how does it work? Here you see the code of the Java class called service of the web API microservice. In that example, we use MicroProfile annotation fallback. With fallback, we can identify the path to use if an exception happens. MicroProfile will automatically invoke the fallback method for us. This is one option to implement resiliency in our Java microservice. In the code of the Java class service, you can see the public method fallback no articles service, which returns the last loaded cached articles. So if the method getArticles is invoked, we ensure, even if there is a problem, that we provide to the front end useful output when other microservices are not available. Here is our example front end. You see the running application, everything is okay, but now we stop the authors and the articles microservice. So let's see what happens. The front end shows the last cached articles, but with no detailed authors information, but we have useful, meaningful output for our user. So that is the case how we can handle that. We come now to the topic with observability. With all these microservices, we're living in a very dynamic environment. Kubernetes, for example, maybe deletes a pod on a one worker node and restart it on another worker node because they want to balance the load inside the cluster. So how to observe all these stuff? That means observe the distributed services, the chained invocation, with tracing, a common logging, because you have all these different microservices running and logs, how to monitor them, matrix and health checks. So when we compare a microservices application with a monolithic application, the microservice world is a little bit more complex than the monolithic because of the many distributed services and chained invocation. But that's the reason why Kubernetes and OpenShift platform and additional tools come in place to help. So Niklas will show us one concrete example for distributed logging, how it works.
Yeah, microservices and cloud-native applications give you a lot of benefits and advantages. However, there are also new challenges that developers and operation engineers need to be aware of. And one good example is logging. Classically, you had one log file where you would find everything for your application. Now, obviously, that's not possible anymore. You have multiple microservices, and they can even be implemented in different programming languages. Now, in order to do logging in that case, you need to have something like a distributed logging component, and fortunately, we have one in our catalog. So the IBM Cloud Catalog comes with IBM services, but also third-party services, and in this case, we use one of these third-party services. It's called LogDNA. Now, in order to demonstrate that, we're going to use here our simple example again. And this is here the dashboard from LogDNA. And as you can see, when the web API is invoked, it also invokes automatically the articles and author service. Now let's get one step further and let's make it more interesting, because one of the reasons why people or developers use logging is to find out where an error occurred. And let's just simulate an error. Let's shut down the author service. And when we now go back to the dashboard, you can actually see that this error occurred in the author service. If you want to get started with microservices, we recommend to use our cloud native startup project. It's available on GitHub in the IBM GitHub organization. You can find the link here in the lower right corner, or simply Google for it. Now, everything that we have shown today is available in that project, but there's also much more. For example, there's a whole section about security, authentication, authorization, encryption, and another bigger section about reactive programming. There's also a lot of documentation. I think we have written around 50 blog entries that go in a lot of detail for all of these separate parts. You can run the example on any Kubernetes environment. That can be the Kubernetes service in the IBM Cloud or OpenShift in the IBM Cloud, or you can run everything locally, either using Minikube or the code-ready containers. We also focused a lot on first-time experience to make it really easy to install everything and to make developers productive. So we have implemented scripts for everything. We can deploy single services, we can delete them, you can easily find out all the URLs. So it should be really easy to get started.
As Niklas said, our example runs locally, but also on the managed IBM Kubernetes service. You can very easily instantiate a Kubernetes cluster in IBM. That instantiation is much easier than a setup locally and provides the same look and feel. In IBM Cloud, you have the freedom to configure the worker nodes to your needs, and the master nodes are fully managed for you. IBM is very close with the updates of the versions of Kubernetes because IBM uses Kubernetes also for IBM Cloud services. The IBM Cloud Kubernetes service also includes the option to easily add and manage Istio or Knative to your Kubernetes cluster. And by the way, you also can instantiate your cluster on a bare metal. That means you get a dedicated physical server inside an IBM data center. A managed Red Hat OpenShift is also available on IBM Cloud, so I would say you should check out how it works in one of our hands-on workshops and feel the difference between the usage of Kubernetes and OpenShift. So, Niklas, your closing words.
Okay, so that brings us to the end of our talk. Let me just summarize the key messages. First of all, the link or the QR code is a link here to our GitHub repo to the Cloud Native Startup project. Then next, we recommend to use as much platform functionality as possible. In other words, functionality provided by Kubernetes, OpenShift, and Istio. Only if that's not possible, use programming language specific frameworks like MicroProfile. Then I also hope you will really remember that IBM loves open source and IBM loves developers. We started 25 years ago with the Linux Foundation, with Apache, with MicroProfile, and also most recently we have contributed a lot of really cool projects like our OpenG9 or OpenLiberty, and we also contribute in many other open source projects like Kubernetes. The other interesting source you should be aware of is IBM Developer. It's our website for developers, and it comes with lots of tutorials and workshops and videos and everything you need to get started with microservices and Java and containers and many more technologies. And last but not least, you should be aware that we have a Lite account. Everyone can go to the IBM Cloud, register there for free. You don't need to provide a credit card, and the Lite account doesn't expire, so that you have plenty of time to try lots of our services that are available as part of that Lite account. So that's everything we wanted to cover today. We hope you enjoyed it. Bye bye and talk to you soon.